Ну что, можно потихоньку начинать. 10 минут 8. Здесь какое-то эхо. Раз. Так, коллеги, рад вас всех приветствовать на очередной нашей встрече московского сообщества Java-разработчиков. Сегодня мы... Как это здесь работает? Ладно, вот так. Спецэффекты. Встречаемся в преддверии завтрашней конференции J-Point, которая пройдет в Центре международной торговли. И у нас такая получается конференционная припати. И хочу вам напомнить о том, что в октябре будет конференция Джокер, и мы уже принимаем доклады, и уже есть заявки. В общем, программный комитет работает, он никогда не останавливается. И еще в качестве такого анонса, пользуясь служебным положением, завтра эксклюзивно на J-Point, день номер 1, зал номер 2, 15:30, начинающий докладчик выступит со своей речью, вот сеанс черной магии с разоблачением. Соответственно, поговорим про Spring Boot и такую технологию, как Extend, и как мы их вместе, соответственно, используем. Ну и магии там тоже немножко будет, и мы ее, конечно, разоблачим, чтобы все было хорошо. Соответственно, если не найдете других интересных докладов, приходите. Кто завтра планирует быть на J-Point? Много. Класс. Соответственно, начнем с представления наших гостей. Гость номер 1 Рустам. Рустам, привет. У нас традиционное рукопожатие. Посмотри в камеру. Это на память. Вот, пойдет потом в мою галерею, где я со всеми знаменитостями. Рустам приехал из Норвегии, город Осло, да?
Да, Осло.
Вот, это где-то далеко. Он, соответственно, лидер местной Java User Group, которая называется Java-Bean, да?
Да, был.
Был. Участвовал в ее создании, соответственно, да?
Не очень. Это у нас уже лет 17. Это...
17 лет?
17-18 лет, да.
Ничего себе. Очень давно. Но проводишь конференцию JavaZone.
Да, так есть.
То есть ты такой аналог Алексея Федорова из Норвегии. И вы оба Java-чемпионы. А в каком весе? Полутяжелый. Я так на глаз определяю. Шутка, кстати, от Алексея Федорова, которого мы только что упомянули. Вот. И еще один гость, это Александр Тарасов из компании «Одноклассники». Вот. Александр у нас уже бывал. Александр, войди, пожалуйста.
Я из кадра выйду.
Класс. Спасибо. Александр, он, в общем-то, программирует более 11 лет. Да. Вот, и в основном практически на Java, но, я так понял, согрешил с новой перспективной технологией, и сегодня, соответственно, расскажет об этом. Вот, и очередность у нас такая будет. Сначала выступит Рустам, потом мы сделаем перерывчик, а потом будет Саша со своим докладом. И вот такая вот у нас программа встречи. То есть сначала у нас доклад на английском, вот с непереводимым названием. Как бы ты сам его перевел?
Решение проблем.
Класс, ну и я примерно так же. И второй доклад у нас, соответственно, про автоматизацию экспериментов. Ну, мне кажется, все подобралось вот как одно к одному. И, в общем, мы готовы начинать. У меня вот только один слайд с контактами. И я хочу напомнить, что у нас есть официальный хэштег в Твиттере. Твитят пока в основном докладчики. И их твиты пользуются большой популярностью сегодня. Если у вас есть какие-то вопросы по проведению встреч, предложения подать доклад и так далее, пожалуйста, пишите. Мы все это получаем и читаем, и будем потихоньку начинать. Вот. С такой цитаты из «Алисы в стране чудес». Вот тоже, кстати, сложности перевода. Говорят, у Льюиса Кэрролла было немножко по-другому. Рустам, давайте тебя переподключим.
Да, давайте.
Включаем.
Так. Штаны превращаются. Брюки превращаются. Превращаются в брюки. Так. Вот, пошло. Вы не будете меня сильно ругать, если я буду по-английски? Сильно. Так, чуть-чуть можно. Окей. Просто выбор, либо меня слушать, как я буду запинаться, либо по-английски. Потому что я уже лет 18 в Норвегии. Нет, 17. Так что вот так вот. Окей. So, today I want to talk to you a little bit about semantic technologies and talk about how things work and how can you explain things to a computer to give a little bit more of content to a computer. When you say things to a computer, when you give a sentence to a computer, it's kind of really difficult for it to understand what it actually means, right? And it's like for me and you, it's pretty easy. I'll try to show you one of the ways of doing that, and also it might be a little bit less known of way of doing that, but actually what I'll get back to that in a little bit, but it actually is being used by quite many companies and many solutions. It's just they kind of avoid the S word, and the S word is kind of the same as the F word in English kind of thing, but as the semantic kind of word is like kind of tend to scare people, so they kind of avoid that, but they still use the same thing. A couple of words about myself. So, my name is Rustam, and I work in a consultancy company in Norway. I've been working as a consultant for the last, 11 plus years. I've been doing mostly Java development. I have, as you guys have said, I've sinned. I did some .NET sometimes, very seldom, I promise. But mostly Java, so I've been doing development, so now I'm working with architecture. I worked with quite a few projects based on semantic technologies that we have been doing. I'm also a tech lead or a lead for a group for architecture integrations at my work, and these kind of things. As it's been already told, I used to be a leader of Norwegian Java user group, which is kind of like Java group kind of thing. I mean, it's not just like Java user group Oslo, Java user group something, Java user group something. We're actually one Norwegian user group with like 6 different regions, chapters, call it whatever you want. It's kind of the American president and the leader of Java Ben. It's kind of the same thing. We cannot do it more than 2 periods. We have to go and leave it to someone else. So that's what happened to me. And so after that, I took over a leadership of a conference that we're organizing called Java Zone. So it's around 3,000 plus people in Oslo in September, and it's I think one of the, if not the biggest, one of the world's biggest community-driven Java conferences out there. So it's actually pretty cool, and we also did that. I mean, Java Zone's been out there for 17 years, and the JUG was there for, I think, for 18 years. Last year I also got the title of the Java Champion, which is really, really cool, and a little bit scary. But yes, so this is a little bit about me, and a couple of raise of hands about you guys. Have you any experience with semantic technologies, or like RDF, RDFS, Jana, anything that I say makes sense? Oh, good. Okay, I almost thought you were like, but you stopped. Okay, no one. Good. Then it's good. I want to show. I usually, when I do things, when I show things about this kind of technologies, and Jana is a Java library for doing that. And there is a semantic technology kind of thing where you have the RDF, RDFS, and OWL, and things like that. I'll get back to that in a little second. So, but the thing is, I usually try to show it on a simple example. And the simple example here is, it's all about the zebras. Not the, I mean, well, it is about the animals, but not those cute ones. It will be kind of in a text form. The thing is, it is about puzzles like this. So I know it's a wall of text. I know it's a lot of text, but, well, I had no choice. It is actually the puzzle, the whole thing. How many of you have seen something like that? There is like 5 houses, there are 5 people, 5 drinks, 5 pets, you know, right? And then usually you have to do all those calculations in your head because you have to build that model in your head, and then you have to kind of deduct who actually owns the zebra, because usually it's 2 questions: who owns the zebra and who drinks the water? Who drinks water? Well, the questions are a little bit different. The puzzles are a little bit different, but the whole idea is the same. So that's why here, that's where the zebra part comes from. Yeah, exactly. So just to kind of review, it's the way it works. You have 5 houses, 5 people. Each of them have a pet. Some pets you don't know who owns what. Some of them you know, and there are some kind of set of instructions. And this is what we kind of will try to solve to explain how the semantic technologies work. So what is going to happen is that we're going to spend, this is kind of timed thing. So the whole circle is 1 hour, right? So we're going to spend a little bit of time on theory. I'm going to actually explain what that thing is about. And then I'll show you kind of 3 simple examples to get started. And then the last one, the whatever that color is, magenta. I don't know. No, it's not magenta. But the light blue color thingy. Example 4 is the one, actually, the zebra thing that we'll try to solve together and see how far we'll get. But okay, let's talk a little bit about semantics. So semantics is actually like, as I told you, it's a way of giving a meaning to something. So if I and you and everybody else sees the sign like this, we know what's it about, right? You know, well, it's me as a person, and this weird red thing is a heart, which is a symbol for love, or like kind of nice, good feeling. And then those 2 letters there, it's actually not just 2 letters, it's actually short for a city, and that city is in US, and you know, those kind of things, right? The thing is that, well, you and I, and we kind of in general, most of us will understand that, right? Computer will not. The computer will be like, okay, there is 1 character, then there is like a weird smiley, and then there will be 2 more characters, and I don't know. One thing is that you will have to, like, either you will have to hard code it for exactly this sign, and then the sign will be different, and things will be different, and you have to hard code it again and again and again. It kind of sucks, right? So the thing is to explain things to a computer, to give it kind of a set of rules or set of kind of triples. We'll get back to what triples are, but it is actually triples. So it's actually 3 subject, predicate, and object. But we'll get to that in a little second. So the way it works, so you have a subject, which is I. This is a fantastic drawing of myself. I worked really hard on that. And then this is a really fantastic drawing. I worked on that one. No, I didn't. I actually found that online. But it's a picture of New York, right? So you have a subject, you have an object. And then there is some kind of relationship in between. And that makes a triple. So you have 3 things. You have a subject, which is I. You have a New York, which is an object. And then you have a kind of relationship in between, which actually explains how those 2 things are connected. And there can be lots of those triples. The way you do that, the way you define all that kind of stuff, you actually create many triples. You say, I love New York, and then you say, I am, or I have name Rustam, and I am a person, and you know, all those kind of things, and you do like in triples. And you can just think of it as a huge one, ginormous table in a database with 3 columns. That's it. No relationships, no like other tables and things like that. All right, but the thing is, so yeah, this is a subject, this is an object, and this is a predicate in between. And those predicates can be different, so you can create many triples like that. You can be I love New York, or you can also say, you can create even rules. You say like, okay, if it is a city, and if it's a person, and the connection is loves, then me as, for example, as a person working in a travel agency, I assume that when people love this, some kind of city, they would like to travel there, right? So you can say something, okay, then that means that that person travels to, and then maybe I should push some advertisement to that person or whatever, you know. So you can actually do a little bit of deduction from that kind of things when you create rules. When you create this, your little world, your little piece of reality, I mean, that little thing will never explain. It will be extremely hard to explain the way we have this picture in our heads, because our picture is a lot bigger. We know that it's a city, we know it's a big city, we know it has like skyscrapers and blah, blah, blah. Computer doesn't need to know all that until you give it to him. But still, you can put and you can add all that information on top of that. So, all those 3-4 letters, weird words. And the last one, the owl, it has nothing to do actually with the birds, you know, the big-eyed birds. It actually has to do with, I'll get back to that. Hold on to that thought, and just you can wonder what that actually means, but okay. Let's start with RDF, because that's the kind of the basic thing of the whole thing. It stands for Resource Description Framework. So this is the way to explain things to a computer, to build your model. So if you think of like UML diagrams, right? You have those boxes and arrows and, well, lines in between them, right? So in that world, in the world of UML diagrams, it's basically those that lets you define classes. You define a class or like a square, and you put some attributes about the thing, right? You have a person, and you have, okay, well, person has a name, and this and that, and age, and whatever, and gender, and I don't know, right? So this is your vocabulary. The way you build, the way you teach a kid a language. It's kind of the same way. This is kind of the same way you teach a computer what it actually things mean. So first you build up a vocabulary. You say, well, this is a car, this is a person, this is a dog, and you know, and so this is what you do. So then you do a next thing. You want to connect things. You say, well, you know, a dog is all dogs are animals, and or whatever, you know. And then that comes to the next kind of expansion of that thing, which is RDFS. Which is RDF schema. So it's that's what it stands for. So it's RDF schema, and that is all those kind of connections between those classes. So all the arrows and everything, that's where RDFS comes in. So you have things like class, subclass, domain, and range, and things like that. Domain is like what that property can be applied to, and range is like, you know, what it can. Domain is like what it can be, what subjects it can be applied to, and range is what objects it can be applied to. I'll get back to that again in a little bit. Just hold on to that thought, right? And then you have the last one, which is kind of even wider expansion of the whole thing again. So first you build up your dictionary. Then you explain how things are connected, right? And then the next thing is OWL. OWL is actually stands for Web Ontology Language. Who would have thought? And then they kind of switch the letters just to make it easier to pronounce, and then it's kind of cooler as well. And well, OWL, I think it may have been something to do with the knowledge and, you know, the kind of the things that those birds are usually connected with. Those are kind of sets. It's not the Olympic rings or anything, it's sets. So this is kind of the sets theory. That's where it comes in. So you can say all men are human, all women are human, all humans are mammals, you know, all those kind of things. And it's like, but there are some other subclasses of mammals, and, you know, so you can do set things. You can do restrictions, you can do intersections, you can do equivalent classes. You can say that, well, for example, you can even do it with different languages, right? You can say that a dog is a same as equivalent class to a собака, right? Or something like that. But, well, you don't do that with languages anyway. You would just add a property, but that's not the story. Just to show you an example, so a short example of the syntax. So this is one way of writing it down. This is one way of explaining and putting those triples together. And in my opinion, this is the most kind of the human readable version of that. Because you can do that also with XML. Who wants to read XML? Okay, there are one person and one person. Okay, go. There is a version. Good news for you is there is a version that you can do exactly the same thing with XML, so it's cool. But for the rest of us, I think this is a little bit more easy to read. So this is an example of like classifying settlements, cities, towns, and things like that, right? So on top of that, you just define your maybe I can do, I can do like this. So on top of that, you will just define your namespaces. You say, well, I have an EX namespace, I have OWL namespace, RDF namespace, and those are actually the ones that you use that are built in. So OWL and RDF and XML and RDFS and all of those XSDs, those are defined, ready defined dictionaries that will help you to define things. You can actually use those to do something further on. So here you say that, well, I have, there it is. I have my class, which is a settlement, and that belongs to a namespace example. So this is something I created. I'm not using that something that has been created by somebody else and kind of defined there. I have a settlement, and then it's a class. Its settlement is a type of class. So you see those triples, right? And then you say also that settlement has, since there is a semicolon and not a dot, if you have a dot, if you have a period there, then it's like, then your triple is done. You're done talking. You say, well, one thing is another thing, dot. But if you do a semicolon, then you can actually, you're still talking about settlement. So you're saying, well, settlement is a type of class. Settlement is equivalent class of. And whenever you see those brackets, this is something called blank nodes. Blank nodes, think of it as, because, let's see, if you look at this one first, you say city is a type of class, city is a subclass of settlement, which is kind of easy, right? And then you say period, so you're done talking about city. Right? This is the easy kind of thing. Those blank nodes there, those are this is kind of the same as saying, well, I have something that has property that is inside there. So what I'm saying, I'm saying that settlement is an equivalent class of something. I don't know what it is. But it is some kind of thing which has a properties of, that is a restriction on a property that it has to be in the country and it has to be from the values that I defined of country and blah, blah. This is just an example. I'll get back and I'll explain to you a little bit more of that in a little bit. Actually, you know what? If we go back, if we just jump back to this, there is a blank node. You will have to use a blank node in one of those. Yeah, this one. So if I have to say, like, for example, the Fuji is a bike maker, right? It's like a kind of bicycle. So the Fuji owner owns snails. I have to say a person owns, a blank node owns snails, and the same blank node owns Fuji. Because I don't know who that person is, but I still have to define it, and that's where the blank nodes come in. We'll get back into that and look into that a little bit more in an example. but this is just a kind of a taste of what to expect. And then you have like a short name that we already seen. You have a prefix of the namespace and then you use a name, right? So the class, it actually is defined in OWL, and OWL knows what it is. So you don't have to redefine all your world together. And the reason it's a good thing to do, to use those existing ones, because, for example, all those, Wikipedia, right? Those Wikipedia has on the right side of the pages, usually there is a little box with like facts for persons, for some kind of things. All that is being dumped to something called DBpedia in the background, which kind of gives you back all that data in semantic version. You can actually get all that defined. And then you can actually do things like, for example, Wikipedia has lots of weird stuff. They have like, for example, all horse races existing all over. Like, for example, all the kind of racing horses defined in Wikipedia for some weird reason. I don't know why. Well, anyway, somebody has a lot of time on their hands, so they're doing all that. And then you can grab the data about all the horse races. And then you can say, yeah, you know what, the Lucky 7, a horse called Lucky 7, I don't know, just a random name I just came up right here, right now, is the same Lucky 7 as in DBpedia database. And then you have all that kind of connected data. Think of it as a graph, right? You have it, one graph there, you have one graph there, and you put those two nodes together, and then you can access both graphs and get much more information about this kind of thing, which is really cool. You can just connect more dots together, right? So this is kind of an explanation of RDF graphs, and this is not exactly, I'm lying to you a little bit, because mathematically, and like by definition of a graph, you have nodes and you have edges in between, right? You have nodes and you have edges that connect them, and that is how it is, right? In RDF, it's a little bit different. That is true. You have nodes and you have connections, but those connections can be nodes as well. Okay? Now, this is like insert the sound of brain exploding. Because this is kind of weird thing, and this is why people like, really strict people that are like really into graphs and really into semantic technologies, they get kind of a little bit offended when you say, well, it's a graph, but think of it as a graph. It's much easier to think of it as a graph until you can't anymore. Then you have to do something else. All right? So, and well, this is a little bit of explanation how it is, right? This is the model of our settlement thingy. You say that you have a settlement, and settlement is a subclass of city, and city has under it, so subclass of that again is the Norwegian cities. And the Norwegian cities has a main country language. Okay, so there is Oslo, which is a Norwegian city, and that one has a main language, which is Norwegian. But then Oslo also belongs to Norway, and there is another thing belonging to Norway that is Veggeli, which is like a tiny little place in the middle of nowhere. But it's not a city, but it still belongs to Norway. So you actually, it lets you define a lot of information with a lot of information lacking, right? You can actually define things, you can connect things, and you can just like break some connections at some point and reroute them and make it even more and more easy to understand, right? So if you put on top of that, you can put reasoning, because I don't know, probably the same goes for you guys, but when I started studying computer science in Oslo, I started at the University of Oslo, they made us take a philosophy class. I mean, like, everybody has to go through that. And like part of it, which was like a classic philosophy thing, like with Socrates and all those kind of things, the philosophy, history of philosophy. But then the other half was actually logic that they made us take. And probably, as most of IT people, we've been through some kind of classes with logic and work with logic and everything. So what this thing is using, the reasoners are usually using, is like first order logic. So it's like on the exam, I had to do some kind of weird thing saying like, well, all swans are white and all swans are birds, so you have to prove that not all birds are white. Things like that, right? And this is kind of where it comes, where the reasoner comes, and this is kind of the same logic it is using in the background. Since you define all these things in triples, you can easily apply reasoning to that thing on top of it. Speaking of reasoning, Google is actually using a lot of this kind of semantic technologies in the back end. It's a little bit hidden. It's a little bit well hidden sometimes, and sometimes it's really, really weird results that it gives you. And it's also to explain to you that like reasoning doesn't always work as it's expected. And this example works much funnier in Norwegian than it is in English or, well, Russian, but I'll try to explain to you what it's actually about. The thing is, there is one of the reasoning engines called Pellet. And I think it's actually in English as well, but in Norwegian anyway, you have those, instead of like putting huge logs in the oven to keep it warm, to keep it burning, you have those small little kind of pressed together little thingies made of tree, which are like small little pellets that you put them into, so because it's like rests of production, blah, 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 reuse, environmental friendly stuff, you know, all these kind of things. And those are also called pellets. And when you Google for pellets and some kind of no query handler found for blah, which is a typical example you might get from a reasoner, and you try to find out what it is, it tries to show you advertisements for those tree pellets that you would put in your fireplace to keep yourself warm, because, well, it's lacking a little bit of context. It's like the reasoner not always is doing the right thing, or you have to build a better model. So it's just an example of saying that, well, look, out of those pellet things, those advertisements that I got on the side, I think one, maybe two, no, actually maybe three are okay, and the rest is just, it's about warmth and how pellets are made, definitely not talking about the reasoner, and you know, all those kind of things. And then you kind of sit and wonder what's actually going on. But the thing is, again, reasoner is as good as what you train it. And it's very popular right now. People talk a lot about machine learning, and machine learning is a totally different way. Machine learning usually kind of relies on doing things, it's kind of a black box. You say, well, this is the input, I want output to be like this, go figure. And then it just like does something, and then it's like, oh, I think I found it, and then it kind of sorts it in a good way, and then you're happy. But you have absolutely no explanation whatsoever how that thing is done. And that's why it's like not always, I mean, imagine using machine learning on your bills. You get a bill from a phone company, and it's like, well, we think you should pay us this. And we don't know why, but I mean, our reasoner said so. I mean, our machine learning thing said so. You know, but then if you do instead, you use the reasoner thing, you use the rules, and you define things, it actually can show you the way it deducted things. It actually explains you. And this is a cool thing. So, back to examples, right? The first one is an example, it's a very simple example, just to show you, just to get you started. You just read a simple hello world statement in RDF, in the turtle format. Turtle format is the one I showed you on the screen a couple of slides back. Then you print all the individuals in the model with Jenna. You verify that the only individual is there, and it's Joe, and it looks like this, and well, you're done, right? The turtle file looks like this, and I'll show you Java code in a little bit. I didn't do the live coding for this one because, well, it's not really important, this part. I just want to explain you. You see those prefixes, right? So I'm saying, well, I have an empty prefix, which is, well, something I came up with, I made up. So Joe is something I created. I'm saying that, well, he has sent message, hello world, and that's a little hat XSD string is actually something to tell the computer that that hello world thing is a string. It's just a little bit of metadata. You can also do it with languages and things like that. You can also say, well, the language is English, and then it's exactly the same thing as something like something else in Russian or something else in Spanish or whatever. The Java code looks like this, so it's pretty simple. This is the Java library. This is where it comes to the action, and then you create a little bit of model. You can read it from. I just want to show you that it's very simple. We don't really have to read the code, but then you just get all the individuals. You just and then you print them. Pretty straightforward, right? All the code and everything builds and is available on a GitHub repo that I'll share with you at the end of the talk, so you can actually try those things on your own. Example 2, which is like a little bit more advanced. The first one is like kind of to check that things work, right? Then you just like, okay, did I install everything correctly? So you can just run that that code and see if it actually works properly. The second one is that you have to recreate the model from the file, but you have to do it with Java code instead. So just to show you again how things are done in Java. Java is an Apache library that is being used for this kind of things, to define things together, put them together, right? Well, those 15 lines of code does that for you. You will end up doing most of the definition and everything in a file, and then you will read it. But this is just to show you how you do that instead for the code. You can do that as well, right? More reasoning and Java. I've showed you all those kind of the basics, right? A little bit of the basics. And what I actually can tell you also is that it is being used by quite a lot of things that without us really knowing it. I mean, how many of you ordered tickets? Usually, I've seen it in Gmail. I don't know if it's anywhere else in any other kind of email clients or company providers or anything. But in Gmail, when you order airplane tickets from like companies that Gmail is aware of, like kind of biggest ones, and those that provide that information, I've seen that especially with Lufthansa, for example. So if you order tickets and get the tickets sent to your email from Lufthansa, usually your email looks a little bit different. Instead of being like just a text, you get those little flips saying like, well, you have a departure and the date and everything, and then you get another flip, another tab on top, which is like arrival and all those. How many of you seen that? Yeah. You know how that happens? No. That stuff happens. That is what actually, the thing is that the text that is being set, if you go and have a look into the ugly HTML version of that, what is actually behind and being rendered. What happens is that it actually has like colon something, like tickets, colon departure, colon. The thing is that there is a defined library for tickets, and there is a defined things, and they just tag the information with the right tags, and then actually Gmail can machine read that and know, oh, this is a ticket, oh, this is an arrival date, and oh, this is the departure date, and I can put them together and show them in a pretty way. This is actually exactly the same thing, so you might have not seen all that things I'm trying to show you, but you've actually seen the results of it, because usually it's hidden, and usually the S word is kind of, nobody talks about it. Or actually, another thing I will show you. Like, I know I'm going to do a little bit of advertisement of my own thing anyway, but it's not the point really. The point was to show you a simple blog post, right? Which is just text, nothing else. It's just like this. But if I do it like this, and if I put it on, well, Facebook, this is fun, always fun to post things on Facebook Live, whatever shows up on your screen. But anyway, if I do this, see what happens? It actually managed to get the title, a picture appeared here, and it knows where it's from, and it actually has a short description of things. And that short description is actually not being scraped from the, well, actually it is in this case because it's the same text. But in reality, I could do the different text. I can have a little bit longer description there, and I can do a shorter one that is being shown here. And you know how that happens? There is something, okay, again, same kind of thing. If you look at, okay, let's inspect. So if you look at the HTML of that thing, no, I don't want to do this. I want to show you the page source. Because it's much uglier, but it's a bit more compact. And then we zoom in. So there is a lot of this LD-JSON. That's another way of like doing a semantic data kind of stuff. So this is linked data JSON. So it's a JSON with a little bit of extra tags. And it's also, there is a lot of meta information. Say, well, there is a Twitter, from the Twitter class, there is a creator, and this is this guy. And it's a type person, and it's a type of blog posting. And, well, the picture, where is the picture? Mind the gap thing. Yeah. This is the description of the picture, so this is what you should show when somebody tries to request that. And this is being done by something called OG. So if I look for, is it OG? Yeah. So it's Open Graph. It's something made by, I think it's Facebook who made that. And then you add those properties. And it's exactly the same way of the way of doing with semantic technology, which is basically what it is. You just say, well, it is a title, and this is the title, and it's written in English, and and blah blah blah, and URL is like this, and things like that. So there is a lot of things like that happening without you noticing, and this code is being generated. It's not something that I write. I just use a right plugin for that, right? So this is just to explain you things that it's not just something weird and crazy I'm talking about. I'm talking about something actually that is being used in one way or another. So, a little bit more of reasoning and general. Way of what you can do is, like, say you have 4 classes. You have Frank, you have mammal, you have human, you have Anna, right? And then you have to do some kind of relationship between those. You can say, well, Frank is a human. Okay, cool. Frank has child that is Anna, right? And Anna is a mammal. That's reasonable thing to say, right? But there is a lot of things that are missing here, right? This is from as of now is a regular graph, right? You have nodes, you have edges, everything is good. But the thing is that you cannot say that Anna is actually human. Well, she's a mammal. She could have been, I don't know, a horse for that sake. But the thing is, well, since me and you, we know that, well, if a person has a child, well, there is a chance that it's actually probably a person, right? Computer doesn't know that, but you have to explain that to him, right? And there we're ready to break all the graph thing. This is the breaking of the graph thing. You put a restriction on an edge, on a relationship, and saying that, well, you know what? Has child can only be applied to mammals. And then what happens is that you automatically realize that, oh, well, you know what? If it can only be applied to mammals, then Frank must be a mammal. Ooh, cool. Or you can do the other way around. You can say, has child is in range of humans. And then you will also say that Anna is a human. So this is why you don't say that it's just a pure graph. It's actually not anymore, because suddenly this thing is both a relationship and actually an edge at the same time, which is kind of difficult to explain, but well, there you go. Right. This is how it will look with the code. you will get to look at the code in a little bit, or on your own if you want to, if that sounds interesting to you. And let's do a little bit of the code things, code stuff. I want to keep the this slide kind of close because I'm going to use it as a. So this is the exercise, right? And then we go to. That's kind of small, right? If we close the project part and we zoom in a little bit. So this is how the turtle stuff looks. And this is actually pretty cool. You should have a look at that if you have a chance, if you want to have a look later. Because here you do a little bit of tricks and you define a lot of things that I defined for you. And then what will happen is that you even have to define, I mean, it's a very simple model, right? You have very few statements, but those statements give a lot of information, and you have to put all that in code. You can, for example, you have to actually tell that, well, you know what? House 1 is actually to the left from house 2, and 2 is to the left from 3, and so on, right? And here you also use blank notes, like I just want to find a simple example for the blank notes. Oh yeah, there it is. So somebody, I don't know who that is, drinks coffee. And the same somebody, I still have no idea who that is, lives in something that has color green. Right? Because the thing is, I don't know which house it is, so I cannot refer to it by a name. But I also defined a little bit further up here that everything that has property, has color, is a house. Which is kind of weird in our world, but for this example, it's perfectly fine. So you don't have to make it complicated. You just keep it simple, right? The thing is that what is missing here is let's see. Okay, so if we look at this, we have some statements here, right? And then we're missing a couple of them. 2, 3, 4, 5, 6, 7. And the way we actually created the code is that if I build it without tests, it will be fine. But we actually put all those kind of questions, who owns zebra, who drinks water, and things like that, as tests. So until you actually fixed all the tests, it will fail. So let's see what we can do. We can do like, let's do statement 2 together. I think I have like 10 more minutes, so I think we should be fine. Statement 2, all right? We can do that together, I think. Statement 2 is Englishman lives in the red house, right? Any takers? Anyone? So Englishman, we have defined like Englishman, right? So you can actually say like this. Then it should be something like, there should be a property lives in. Has color, I think it was green, right? Red. Red. Okay? So, Englishman lives in something that has color red. I don't know which house it is, so I cannot refer to it by a proper name. But I'm just saying like this, right? Pretty easy for us to read. But it actually makes it readable for computer, which is cool. the Spaniard owns a dog. Okay? Any takers? Spaniard. This. The property is called has pet. That's it, right? Because, actually, if I break the tests, if I run all the tests, it will break. Well, while it's building there, we can... you see it actually is printing all the possible things that it knows. And what happens is that it's running reasoner in the back end, and it tries to build more information on what you actually have put in. So this is exactly the same example. See, the tests failed, right? There are test failures. That's because we're not done with that stuff yet. But the thing is that it's actually what it's trying to do is actually exactly the same thing what happened with this thing. When we put in the domain thing and we build a model, it built this little red dotted line thing, which wasn't there, it's not defined, but it actually is able to reason because, if has child can be applied only to mammals, then Frank has to be mammal. Or has child can be told about mammals, right? Then Frank is mammal. Okay, number 4, we seriously have to do together. I've done 2. You need to... coffee is drunk in the greenhouse. So, what do we have? We have a person that drinks coffee, and the same person lives in greenhouse, right? How's that going to be?
Maybe a dog drunk in coffee.
Yes, it could be, but in our model, well, no. The animals don't eat, don't drink, they don't smoke, they don't do anything. So it's like, it's up to your model, right? So this is a model, it's very simple, and it looks like this. So if you want to make it more complicated, it will just be more pain in, where. 4. Coffee is drunk in a greenhouse. We know that according to our model, it has to be a person, right? So we're saying that, I haven't looked in the solution for now, but I think it's going to be something like this. The property is called drinks, I think. Or has drink. Yeah, drinks. Yeah, that's good. So, help me. What's going to be? Drinks, coffee. If I manage to spell coffee. It's a thing now this year, right? With the coffee. Guess it's a new word now. Okay, so somebody drinks coffee and lives in a greenhouse, and then lives in something has color. Now the reason you start all of those things with a column is that you should do a namespace in front. And to simplify things, I defined an empty namespace up here, which is my own. I could have called it Rustam, then I had to type Rustam every time, which would be really cool if I would be really, really obsessed with myself, but unfortunately I am not that much. So then you just do like, okay, I'm done talking, so dot, right? And then the 5th one would be like Ukrainian drinks tea, that's easy, right? Ukrainian and it's been a long day. Yeah, sure. The good thing is this IntelliJ actually does spell check. It's actually really nice. Because if you do like this, then it will be kind of mad. So you want to do more, and we can just instead we can actually do. The good thing, there is actually a magic folder hidden there on the code called solution, so you can actually always copy paste stuff, which you don't have to. So you don't have to do all the other ones, which is nice. So you can do something like this. Since I'm running out of time, and then I am afraid that we might. No, actually, it will be fine. I will go into tests, Java, exercises. I think it should be fine just to run this one. So this information, what it actually says here, it's all the statements that are in the original puzzle. There is no information about who drinks tea or who owns zebra or anything, or drinks water. But if everything works now, live demos are always fun. It's still green. The tests are green. So if it gets all the way green, then we're good. And on top of that information, we're running a reasoner that uses the first order logic that is trying to find out who actually drinks water and who drinks tea. Who drinks water and who owns zebra. I don't know why I'm talking about tea. I guess I'm thirsty or something. So it takes a little bit of time because it kind of finds all the possible permutations of everything. And we'll look into a little bit into what actually it spits out. Okay. Hey, we have green tests. Nice. So it actually worked. So all the statements that we created here that are part of the puzzle, that's all that is in there. There is still no information about zebra, but we have them in here. What happens is that for example, it prints all the individuals. So it starts with, randomly it will pick Japanese because of, I don't know, it's sets, so it picks differently from time to time. And then it puts all those things here. It's like, it's a type of a thing, it's a type of a person, and it's the same as zebra Japanese, and it's also same as this weird thing. Can you guess what that weird thing is? There's lots of those weird things. Those weird IDs, they're different. Can you guess what that is? You remember those blank notes? That's it. Because it doesn't know what it is, so it generates an ID and says, I don't know. And then it will try to figure out what that blank note is. And then same things like it's individual null. That's a very nice individual. And then there's another one. And then, there's a Norwegian one. And then all the information about the Norwegian. So it actually, is it different from house 2? So we know that it doesn't live in 2 or 5. Oh, wait, I'll do like this. And he is not owning a Trek, which is a bicycle make. And he is not owning a horse. Okay, good. So it prints all this kind of information. So if you scroll down a little bit more, you know that... Okay, let's cheat. Let's just search for it. Zebra. You ready to get the answer to the universe and everything? Who owns zebra? It is not... oh, fuck. This is fun to call, actually, to search for zebra. But we can do, actually, we can cheat. We'll fix that. That's okay. Zebra, like this. No, like this. There. So it's different from this. Oh, has pet zebra. Who can that be? Hey, it's Japanese, actually. So first it actually realizes that it's different from zebra, so we know that Japanese is not a zebra. Cool. There is that mystery out of the question. But then we actually know that the same person has pet zebra. So, okay, Japanese, cool, good for him. He has a fun pet. But who drinks water? Water. Ooh, drinks water. Okay. And all that information has been deducted from the reasoner, right? So we just suddenly realize that somebody drinks water, and that would be, hey, surprise. Then we have to keep on searching, because the thing is, there are blank notes, there are things that it doesn't know, so it's just like, okay, well, I don't know what that is. Okay. Maybe we can actually do even different from water. Drinks water, okay? Tension is rising. Woo-hoo! We have that one. So we know that Norwegian actually drinks water. And all that, most of that information is garbage, right? There's like weird numbers and stuff. But there is a lot of good information that is being deducted here and that can be actually given to you. And this is pretty cool. You can actually put that stuff into a separate database, separate triple store, run on top of that. You can run a reasoner. You can do two things. I mean, it's like those of us who had the database theory, right? When you can do optimization or re-indexation or whatever on insert or on query, or you can do like checks and things like that, right? The same thing you can do here. You can do reasoning on insert, or you can do reasoning on query. And that will depend on how much time it will take to do query or insert, right? So it's exactly the same idea. It will just do one of those will take longer time. I think we're good on time, right? 3 more minutes or 4 minutes or something, right? Yeah, good. Yeah, that's pretty much it. And this is, I don't know if that did you learn anything new today? Ooh, yes. Hey, nice. You know what? I'm used to Norwegian public. Those guys they're very nice, but they're very quiet, unless they're not drunk. So I'm kind of used to like everybody being quiet. So it's like, for me, I'm in heaven right now. People actually answering. So thank you for that. Yes. This is the code. The whole thing is on my GitHub. So you can just, well, it's there, but wait, there is a simpler link. Just a second. Well, that link works as well, but there is a slightly bit more updated version of that. That is, and it's easier to remember. I'll do that. Because we put it on my company's GitHub, but it has nothing to do with the size here in this case, right? But, well, almost. There. Well, get ugly. There. Now it's actually readable. It's not OCD, by the way, right? It's CDO, but it has to be sorted alphabetically as well. This is the GitHub repo, or you can use the other one. Doesn't matter. There you can find the code, you can find the examples, you can find the solution for everything, for all those examples I showed you. Those are actually exercises, so you can actually do 1, 2, 3, 4, and the fourth one will be like the fun thing. This is me. This is where you can find me. And do you have any questions? That's another thing I'm totally not used to. Okay, you were first. You were quick. Yes.
Я по-русски буду.
Ну давай по-русски.
Насколько я понял, вот эта DSL штука, значит, она кормится Женя, назовем ее так, она генерит Java-классы, правильно?
Не очень. То есть на самом деле можно... То есть ты описываешь то есть ты можешь либо описать это Java-классами, которые будут, то есть либо сгенерированы, либо как-то, либо же ты просто описываешь это вот этим turtle форматом, или XML, то есть описываешь просто вот этим триплетами. А потом это, что происходит там уже за кулисами, это уже как-то внутри этой Жени как-то это.
На самом деле...
Мне понравилась Женя, кстати.
Пролог такой на Java, да?
Да.
Вот, и там много же открытых вопросов вокруг пролога.
Ну, правильно.
И даталога потом, и там производительность очень связана.
С производительностью это очень, кстати, связано. Это я тоже вот хорошо было бы упомянуть тоже, потому что люди это используют, то есть люди очень такие, они любят вот религиозно относиться к технологиям, да? Типа вот все, говорит, вот это вот сейчас нам решит все наши проблемы. Мы засунем все свои данные только в Triple Store, будем там, значит, это все сохранять, это будем там держать, и это будет у нас так все летать. Просто вот красиво, да? На самом деле это так не будет.
И в итоге там все упирается на самом деле в то, насколько эффективно ты проходишь по этому.
Да,
Чтобы там
все правильно. То есть для этого мы используем, то есть вот у нас было такое, я сидел в проекте, значит, где очень много разного, эквипмента, да, какого-то там для чего-то, не буду говорить что, в общем, тулинг разные такие железные штуки, настоящие такие, винты, краны, в общем, фигня всякая. Описывалось, все это было описано в такой вот модели семантической. И, значит, им, значит, надо было потом спросить, вот у меня поломался такой насос, на какой мне его можно заменить? Эта штука отвечает на это все намного лучше, то есть намного легче там спросить, чем у relational database, да? Но если ты такое спросишь через, то есть есть, например, язык, который называется Sparkle, Semantic, в общем, как SQL, только Semantic версия этого. Если ты спросишь на Sparkle вот это, у тебя ответ будет, через, не знаю, минуту, может быть, или кто-то. Это очень медленная штука. На самом деле мы это заранее генерили, потому что мы знаем, какие будут вопросы. Мы генерили эти вопросы и пихали их в Elasticsearch. То есть использовали Elasticsearch как кэш. И тогда это все очень быстро, да? Но никогда нельзя использовать, то есть мой экспириенс такой, что нельзя никогда эту штуку использовать как единственную базу данных своей. То есть это рядом, это копируется, это рядом, это помогает, но у тебя есть своя. Да, это я просто хотел, да.
Все упирается в итоге в то, насколько ты можешь на лету оптимизировать вот такого рода запросы. То есть насколько ты знаешь, как такого рода запрос помачить на свой график. Вот. И это вопрос открытый, насколько я знаю, то есть его никто еще так не смог решать эффективно. Вот. Но при этом есть такая штука, как даталог, датомик, прошу прощения. Слышали вы, что думаете про датомик? И, то есть там парни, которые вы делали, сказали, что ей-богу, вот они когда-нибудь такого рода оптимизатором не нахренячат.
Если честно, я не пользовался датомиком, поэтому как-то сказать сложно. Единственное, то есть какое вот я видел, то есть решение этого проблемы, это просто, первый, кто спросит, у него будет это долго идти, а всем остальным будет закашено. То есть это что-то надо сверху, потому что дело в том, что вот этот Sparkle, он позволяет тебе спросить все, что угодно. То есть либо надо Sparkle ограничивать как-то, чтобы невозможно, потому что там можно спросить, дай мне все. И он пойдет отдавать тебе все. Только при этом он упадет, потому что у него памяти не хватит, не все такое, да? Потому что это язык такой, он тебе разрешает все делать. Но поэтому я говорю, это очень люди, поэтому сейчас я говорю, S-word, они не любят, то есть упоминать, потому что очень много людей обожглись на том, что они религиозно пошли, что будем все, семантик, у нас только семантик. И у них все падает, идет медленно, в общем, это, да. То есть это надо использовать либо рядом, либо же что-то сверху надо строить, какой-нибудь кэш, какой-нибудь там что-то. Датомик не пользовался, не знаю, не могу сказать. Если мог бы объяснить, как чего они делают, я постарался бы ответить. Если нет, мы просто потом можем обсудить. Да, потом это все. Еще где-то, вот вопрос был.
Вопрос насчет того, как при ответе на вопрос формируется итог ответа. Это какими-то лейси, скажем так, пайпами происходит, или там все-таки генерятся все связи, потом просто они ищутся? Просто, скорее всего, если немного, то все падает.
Сейчас, то есть я генерил все возможные пермутации этого дела, потому что я использовал, то есть Reasoner, да, Reasoner он все дает, и можно оптимизировать, если я не ошибаюсь, то есть я могу наврать, но, по-моему, если я не ошибаюсь, можно даже оптимизировать, говорить, что лучше вот это вот мне выдай, то есть попытайся мне, ну, понимаешь, если он будет стараться тебе только прооптимизировать какую-то часть, он может не получить все ответы, потому что какие-то ответы могут прийти из другой части, да, то есть там какие-то появятся связи, и эти связи приведут к каким-то новым связям, да. То есть поэтому это лучше, то есть вот я поэтому говорю, есть какие-то при запросе, а какие-то при инсерте. И вот надо выбирать уже, choose your poison, да, то есть выбираешь уже, какой тебе лучше подойдет. Сзади там был вопрос, потом там.
Что можно использовать, чтобы человека, читаемого текста, собрать толстым? Потому что вот дать ему вот этот текст, и чтобы он сам из него усвоил. То есть какой-то большой текст, чтобы было классно, чтобы он сам разобрался, а не сидел и плохой вал его.
То есть тулинг какой-то, чтобы переводить язык, то есть язык в, ну да, в Turtle, да? Насколько я знаю, такого, то есть это довольно сложно, это нелегко так строить, да? Но что можно использовать? Вот сейчас, например, там у Google есть, у Amazon есть там все NLP, да? Natural Language Processing. Они, значит, смотрят и знают, они знают, что вот это подлежащее, это сказуемое, это вот это. А потом из этого всего можно собрать вот такую штуку. То есть вот, например, мы, ну, это, в принципе, Google сделал, да, такой демо, но потом я и еще вот парочку ребят, мы пересобрали этот же демо у нас в офисе в Норвегии. Это такая штука, которая называется Candy Sorter. То есть ты приходишь, говоришь, мне нравится черный шоколад. И он, значит, прогоняет это через NLP, ихний, Google Cloud'овский, значит, получает, что окей, мне там нравится, или дайте мне, пожалуйста, там черный шоколад. Он такой, ну, пожалуйста, это мне не интересно, это я выкинул, дайте тоже, ну, это как бы intent, то есть, да, это чего, что кто хочет, ну, понятно, это, значит, хочет, ну, очень хорошо. Шоколад это мне надо. Круто. И потом он это берет и, значит, что-то делает. То есть это можно вот построить, я так думаю, можно было бы построить что-то такое, какой-нибудь basic, такую какую-нибудь штучку, базируясь на Natural Language Processing. Потому что предложения, которые для нас очень легкие, они для компьютера довольно-таки сложные. Что можно опять-таки делать? Можно, например, делать это частично. То есть вытаскивать только какие-то определенные там слова, которые ты точно знаешь, и тагить их. А потом чего ты с этим делать. То есть, на самом деле, мы здесь сделали, вот в этом примере, мы построили еще модель, мы построили там, как это все взаимосвязано и все такое. В билетах, например, да, которых самолетные билеты, я говорил, авиабилеты, там это строится, ничего в имейле такого нету, потому что есть готовая модель билета, там уже все прописано, как чего все связано. На самом деле просто тегится дата, как departure date, arrival date и какое там место, то есть куда, откуда, куда, просто тагится. А потом он смотрит вот по этим namespace'ам, он смотрит, где это что и какие это связи, и уже выдает, значит, какую-то там логическую штуку из этого. Это общий стандарт даже, я сейчас боюсь наврать, но я это гуглил и Gmail. На самом деле все намного проще, да. Ну, то есть есть какие-то, которые из текста вылезают тоже, потому что есть какие-то авиалинии, которые это не поддерживают. И, кстати, у них... вот, черт, вернись. Но на самом деле, когда таги, намного легче, да, с этим всем, вот эти штуки, да, когда выходят в инбоксе, там, например, и все. У них есть два стандарта. У них есть JSON-LD, который это общий стандарт JSON Linked Data, такого же типа, как вот Turtle, только JSON, с тегами. То есть обычный JSON, а вот смотрите, видите, да, вот такие же namespace, вот эти все пошли, все такая же штука, да, type flight number и все такое. А есть еще ихний свой microdata, который, кстати, на XML. И то есть у них даже два формата они поддерживают. Есть открытый, а есть свой. И вот на самом деле можно вот так вот просто, да, и никакого, и ловкость рук, и никакого обмана. Да? Никаких связей, никаких моделей нет, потому что кто-то уже построил эту модель, и она описана вот здесь вот. На schema.org там очень много разных моделей, то есть вполне возможно эти модели строить не приходится. У нас была какая-то такая извращенная штука с домами, там, с напитками, совсем. Такого, естественно, нету, да? А здесь это стандартные штуки, это... Так, ответил немножко хотя бы, да. Еще был вопрос вот здесь, да, был вопрос.
Вопрос такой, вы сейчас пример показали, то есть у нас есть какие-то сущности, вы между ними прописываете, ну,
Да.
связи, какие возможны, какие-то рестрикшены, а как это в реальности, как вы добавляете, это на лету добавляете, то есть вы это, или вы это хардкодите, как вы
Можно, например,
как
это...
вы тестируете, то есть сейчас вот вы, допустим, в да, посмотрели, ну, допустим, если у нас уже есть какие-то описания, каких-то связей, и мы потом добавим какие-то restriction или еще что-то, у нас, ну, результат может быть непредсказуемый, если мы ошибемся.
Может быть.
Вот. Как вы в реальности
То есть вот элементарный, то есть такой самый элементарный вариант этого, как мы вот как использовали в этом коде, да, то есть мы просто добавляли такие тесты, типа, есть ли у нас ответ на вот это, или если у нас, то есть вот как это получается, как это называется, smoke tests, да, то есть ты вот получаешь, просто проверяешь, ты какие-то вещи, ты точно знаешь, что у тебя будут выходить, ты просто по ним проверяешь. Это элементарный вариант. Посложнее вариант, это уже пытаться как-то это выписать. Например, мы...
Вы это делаете в рантайме или, грубо говоря, у вас модель, вот то, что вы описываете, она как бы зафиксирована, да, и добавление новых, это тоже добавление каких-то описаний, плюс добавление тестов к ним, да, после того, как вы какие-то рестрикшены или, наоборот, связи добавили.
Все-таки это, кстати, довольно-таки, если ты добавишь чуть-чуть неправильный стейтмент, это поломает все. Поэтому это проверять все-таки надо, я думаю, вот, например, вот такими тестами, да, можно проверять. Или же можно проверять, то есть вот модель смотреть, как это все взаимосвязано. Но это довольно-таки сложно. Там вот это правильный вопрос, в принципе, потому что это очень это немножко такая нелегкая вещь. То есть приходится как-то с этим связываться. Но какие других альтернатив, в принципе, и нету, да? То есть лучше либо же вот с этим надо мучиться, либо потом все это самому анализировать и соединять. То есть да, это как-то неудобно, это сложно, но вот приходится как-то лучше. Я вот думаю, все-таки смоук-тесты довольно-таки помогают. То есть, если ты знаешь какие-то у тебя там стандартные вещи, если ты их проверяешь, и это ничего не ломает, то вполне возможно, то есть, что это все правильно. Но это сложно. Вот эта вещь, это, конечно, может. Поэтому я говорю, это должно быть в дополнении, это что-то дает какие-то, которые дополнительные данные, и ты должен проверять это, то есть, да. Но это точно так, в принципе, тот же вопрос можно задать и про обычное машинное, machine learning, да, то же самое. Как я знаю, что вот это, не знаю, вот вроде похоже, потому что тестовые данные, да, которые у меня есть input, у меня есть output, по ним все нормально, значит. Есть такой tool, который называется протеже. И эта штука, вот это. И эта штука, значит, вот этот генерит вот такие графы. Это было сгенерировано вот именно таким протеже. Так. Они что-то поменяли сейчас. Они делают так, что картинки сложно. Open image in new tab. Вот такие вот картинки, да, типа что пицца это spicy, там equivalent у нее есть, или еще есть vegetarian equivalent, или что-то такое, это из протеже. То есть протеже это такая штука, вот у тебя все классы, там сабклассы, все. В семантических технологиях, то есть все начинается thing, это как object в Java, да? Все thing, а после этого это значит все остальное. То есть ты когда делаешь вот этот blank node, это тоже thing, только ты не знаешь, какой это thing. Вопрос?
Уже про заголовок, который ты спрашивал, а я бы еще, я с собой еще пошел, А еще, в принципе, то же самое, как
Да.
это еще моделируется графовые базы данных.
Да, графики, да. Neo4j, да.
То есть там просто то, что предикат здесь,
Правильно.
это ретро будет, соответственно, это мы не пробовали, то же самое сделали с помощью графовой базы данных.
Графовая база данных, она немножко по-другому. То есть и по ней можно спрашивать. Да, но там вот с reasoning, по-моему, насколько я знаю, там немножко слабовато. То есть там не по вот этому, ну как это называется, вот сейчас вот начинается терминология, я начинаю вот first order logic, да, вот эта логика, да, это первого уровня, как она там называется. Первого порядка, да, спасибо. Она, значит, там, по-моему, с ней как-то немножко слабоват, нет? Или я ошибаюсь? Да, но по всему графу он все равно будет использовать все вот эти связи, которые у него есть, а новые он генерит. Он сможет типа понять, что вот раз здесь связано так и здесь связано так, то это связано тоже вот с этим. Вот в этом, в принципе, сила этого. И еще вот у тебя, когда два графа, то есть у тебя есть там граф, ну вот не знаю, пиццы какой-нибудь, да, там твоего ресторана, типа у нас вот пиццы, такие пиццы и такие пиццы. А здесь у тебя ты из Дбпедии скачал граф всех пицц и их калорийное там содержание или еще чего-нибудь такое. И ты типа говоришь, вот пицца в этом мире и пицца вот это, они одно и то же. И ты тогда можешь спрашивать по всему этому графу. Это может быть, это, кстати, будет, я думаю, в Neo4j намного легче. Да? Но Neo4j, например, используется намного легче, более интуитивнее, чем смотреть вот эти графы. То есть, вот, например, я знаю, использовалось даже, например, такого данные, просто засовывались тупо в Neo4j, а потом, значит, разные, ну вот, какие-то работники там различных органов, там, ну, например, налоговых или еще чего-то, они просто смотрели на этот граф и, этот связан с этим, а у этого такое, а у этого так вот это, ну тогда, просто они это графически как-то смотрели, да? Так, все, по-моему, время уже вышло, я боюсь.
Ну ты как себя чувствуешь? Можем еще пару вопросов писать.
Я не знаю, вопросы еще есть пока?
Есть вопросы, коллеги?
Будете еще мучить? Допрашивать.
А в Норвегии обычно задают вопросы?
В Норвегии задают тихо, после презентации и где-нибудь далеко. Они не любят так. Так что это...
Вот это российская, да, специально. У нас задают
уже
вопросы.
ответили, просто есть какая-то возможность инкрементально обогащать граф в антологию?
Как? То есть...
В рантайме.
В рантайме, ну вот это то, что мы делаем. Да. А это просто тогда надо записывать просто. Да. Ну это вот то, что мы здесь видели. Это, в принципе, вот это все. Если ты все эти связи просто, делаешь какие-то там правила, чтобы, например, там вот эти всякие страшные страшилки туда не попадали, а все остальные, например, ты записываешь файл, а потом это генеришь по этому граф. И будет у тебя красиво. Или же, например, не граф генерить, а именно просто файл или в базу данных, то есть вот это triple store, это все записывается, и тогда у тебя, то есть, обогащаются твои данные. Ты положил там 3 штучки какие-то, 3 вещи, после того, как reasonable прогнал, у тебя получилось их там 10. Да? Круто, в принципе. Новые какие-то информации. То есть, раз он любит, значит, он хочет туда ездить, значит, тогда я ему могу продать это, и тогда я ему покажу вот эту рекламу. И у тебя уже появилось, значит, уже это.
Не с нуля, из достоверных фактов я это все хочу устраивать,
Ну да.
уже по построенному результату предыдущего.
Ну вот это мы так и делали, в принципе, да?
Я думаю, чтобы хорошо разобраться, надо вот пройти по ссылке,
Надо
скачать,
да.
взять, попробовать,
Построить.
И Рустам можно потом написать
Да.
все свои вопросы, и он с удовольствием ответит. Давайте поблагодарим. Спасибо большое. Мы сейчас сделаем перерывчик, минут 15.